Hello everyone, welcome back. So in this episode we've gone ahead and we've previously taken care of our expressions and our animations and gotten 3D characters working here. So now we just need to take care of the rest of the functions to make sure that they can do all of the things that our other character types can do as well. And we're going to start off with the same pattern that we did for live 2D characters. So we're going to go and make this character able to show and hide, and then set the color, and then set the highlighting and the facing direction, and then you can expand from there as you see fit. So let's go ahead and open up our character model 3D script, and let's go ahead and start adding this functionality. First thing I might do right off the bat is, I'm not sure why I made these public. These constants can be private. Nothing outside of the 3D model character class is going to be using these. So I'm just going to make all of those private and just clean up the variable access a little bit. Okay, and just like we did for live 2D characters, we need to define what makes this character visible. So our sprite, or our regular base character, is visible is actually just getting absolutely nothing. So we have to override it, and we have to tell it what defines this 3D character as being visible or invisible. So let's go ahead and do that right here. Let's make public override boolean and is visible. And so if we are getting the value, then we want to check one of two things. Either is revealing, we are revealing this character, or we want to check our opacity for this character. And we can check that through the canvas group that should be attached to our renderer. We don't actually have a reference to that right now, but just like we did for our other characters, let's just make a quick reference to that right below our renderer. So we can say private canvas group and say renderer CG and point that to renderer.get component canvas group. And so if we're visible, we're either revealing, or our renderer CG.alpha is greater than 0. And we should actually go into our other characters and change that as well, because I think I set that to 1. Yes, I did. So if our renderer opacity is 1, so it's fully visible, that means the character is visible. But what if it's halfway visible? It's still visible at that point. So we just want to check if it's greater than 0. If it's greater than 0, then our character is visible. So let's do that for the last character type as well. There we go. And we're good. And if we're setting the value, then let's go ahead and say that renderer CG.alpha equals, and let's check if the value is true. If it is, we're going to set it to 1, otherwise we'll set it to 0 and make the character invisible or visible. Oh, hold on a second, that shouldn't be renderer CG, that should be the root CG, because this is on the actual image of the character. Those can fade in and out anytime, but the root CG controls the visibility of the total character, so we need to set that up. So that's a bad name there. If we actually look at our sprite character, we have root CG defined. For our live 2D character, we're using something else. So let's just go ahead and change this to root CG instead, and call this root.getComponent canvas group. So let's go ahead and change the references and make sure that we're grabbing it from the root instead of the actual renderer for the character. Now, the next thing that we want to do is we want to override the function to show or hide the character in the scene. And this logic is actually going to be pretty much the same as our character sprite because we're using all the same parts. So let's go to our character sprite and just find that function down here for showing or hiding. So we can go ahead and copy all of that, take it, paste it into this function, and that's actually good because we have all of those same parts. So let's just quickly test that real quick. So in test characters, I'll create Amaria, I'll set her to be invisible so we can check that out, and then we'll wait a second and we'll show her, then we'll wait another second, and then we'll hide her. Alright, she's invisible, there she goes fading in, and she fades out. So that works. Now let's move on from revealing and hiding the character and go to setting the colors. let's start off simple and just set the color instead of transitioning. So we can make the override for the set color right here, and we'll go ahead and call base.setColor. That way we can log the new color of this character. And let's say that renderer.color equals the new color that we're trying to put in there. And now let's just go ahead and call our character set color to something like color.red. There we go. Immediately sets her to the color red. Now, when it comes to setting color, and especially when it comes to flipping our character in a minute, we're going to want to cache the old renderers just like we did for our sprite characters. And then for setting color, we'll go ahead and set the color on those old renderers as well, even though they're fading out. That way it'll keep the uniform coloring across the character, and we won't see any kind of glaring differences. So let's go ahead and define what an array of our old renderers will be. So as we create these new characters, first of all, maybe we'll go ahead and just start the process of... No, I'm not going to do that yet. We'll just talk about it real quick. When we go to flip the character, so far everything that we're doing with these 3D characters, we're not actually creating any new renderers or anything, because the animations, the expressions, they're all running off of the same renderer, because that's just taking the feed of a camera, so we don't need to change anything. However, when it comes to flipping the character, if you are using it as I'm doing here, where we have the render texture and the characters being projected on screen, then there's a certain way that I would like to manage flipping the character, and that is to have it fade out the old direction and fade in the new one, just like we do for our sprite character. When we face left to face right, then we fade between that transition. I would like to do the same thing with our 3D model characters. That way we have that same fading transition, and it's not like an instant rotation or even a transition on the rotation in 3D space for that character. It would just look a little strange to me. So when we create a new rotation for the character, I want to fade it in, and that means I'm going to be creating a new character model, just duplicating it from what we already have, a new camera, a new render texture, and then project that onto the screen as well, and then I just transition between the two. So we'll temporarily have a duplicate of the model. That way we can fade in the transition and have the character at the right rotation. So this is especially important because with 3D characters, you might have different details on one side than the other, so simply flipping the image isn't going to be a viable option. So if we're caching our old renderers, we also need to cache the old render group. That way we can delete it once we're done with the transition. So let me just take this one step at a time. And let's go ahead and define what will go into our old renderers. We're going to make this as a struct. So we'll say private struct old renderer, and inside of here, we're going to want to keep track of a couple things. We're going to want to keep track of the old canvas group. That way we can fade out the actual rendering object on the main character panel. So let's go ahead and cache that public canvas group old CG. So this will fade out for the character. And we also want to cache the old raw image. That way, if we're changing colors, we can apply the color on that object as well. So let's go ahead and say public raw image old renderer. And then let's also cache the game object for the render group, which contains the camera and the actual model for the character. That way, once this is transitioned out, we can go ahead and delete that object. So this will be a public game object, old render group. And let's just make it easy on ourselves by making a constructor for this that will allow us to create this fairly easily. So public old renderer, and let's define a canvas group old CG and a raw image for old renderer. And then, so let's make this the old image. That way that's a little clearer, because they don't want that kind of clashing with the struct name. And then lastly, a game object for the old render group. So in here, we can go ahead and quickly assign these. This.oldCG equals CG, this.oldImage equals oldImage, and this.oldRenderGroup equals oldRenderGroup. So whenever we decide to create a new renderer, we'll go ahead and create this and add it to a list of old renderers. So private list old renderer for old renderers equals new list old renderer. And that will allow us now to come into our set color function and just go ahead and apply this color to all the old renderers as well. So for each var OR in old renderers, then we'll go ahead and say or.oldImage.color equals color. And that'll just keep the color application uniform across the whole character, even if we have old renderers that are fading out. So now let's move on to transitioning our color. To do this, we need to override the changing color coroutine. So public override changing color. And changing color and highlighting, they both operate off of the color value for the renderer, so let's go ahead and just make that override as well for our highlighting. And now let's make a coroutine that's actually going to handle the changing of the colors for both of these functions. This one will be private, IEnumerator, and we'll call this changing renderer color. And we'll take in a float for the speed multiplier, because when we run this, the color is already going to be applied to the base character class as a variable, and we can just reference it from there, so we won't be taking that as a parameter. Now, in changing color, let's go ahead and start that. So yield return changing renderer color, and we're going to change to the speed multiplier, which is actually, I did not name it that, so whoops, there we go. Okay, so we yield for the duration of that, and then we can go ahead and say CO changing color equals null once that's finished, and we're done. Now for highlighting, let's go ahead and do the same thing. Let's yield return changing renderer color by the speed multiplier. And once we're done with that, we'll say CO highlighting equals null. And that just means that our color variable here is actually, we don't need it, and we don't really need the highlight variable here as well. Let's head back to our base character class real quick and make a small change. As I was running through tests of the characters earlier, I found that if we're running a transition of the color and we run the highlight immediately afterwards, if highlight finishes before the transition color finishes, then transition color will actually override the highlighting because of the direct color that we're passing through. Now, when we call transition color, the color that we define is automatically being applied to this dot color, the color for the actual character variable. And if we look at the top, our display color just references the highlighted color or the unhighlighted color, and both of those just reference that color value. So without passing in color directly to those other coroutines, we can still access it by accessing the display color, and that will actually take into account the highlighted status regardless of what we're doing, whether we're just changing a color or we're actually changing the highlighting feature for the character itself. So we don't need to pass color through to the other coroutines. So we can actually get rid of that here. So let's go to changing color. Yep, right down here. And just make sure all we're passing in is the speed. And then for highlight, all we're doing is passing in the speed as well. So that is fine. But for highlighting, we already have the highlighted variable, so we don't need to pass in highlighted, because that is being assigned through whichever function we call. So we can remove the highlighted reference inside of our unhighlight and highlight function, just cleaning things up a little bit and refactoring a little bit of the code. As so in transition color, we can go ahead and remove the display color and just simply pass in the speed. And that means if we come to our sprite character, then let's go ahead and take a look at these two functions. Changing color is expecting a color here. Let's just go ahead and remove that. We don't need that, but what we will do is we'll change color inside of here to display color, which references whatever color we decide to change to. And for highlighting, let's go ahead and remove the highlight variable, because we actually don't use that, and we're not even using that in the function here, so it's completely pointless. So that's good. Let's look at Live 2D and make sure we're good here as well. Okay, so changing color, we do not need that, and we'll just change color to display color. And then for highlighting, let's go ahead and remove that variable, and we look to be good. But I don't need to pass in display color. We'll just change the color and base it off of the speed, because this is our private function, so we'll control the color directly through here. Let's switch target color to display color, as that's the color that we want to change to. For changing color 2D, let's just go ahead and remove that variable. So the only thing we're passing in to the private coroutine that handles the color for the Live 2D character is just the speed multiplier, and whatever color we're trying to set it to, we get from the character class, which receives that color from highlight, change color, and whatever else we may have done. So that should take care of sprite and Live 2D. And for model, let's remove highlighted there, and let's remove color from changing color. Okay. Before we proceed further, let's go ahead and make sure that that didn't break anything. And let's say yield return null right here to satisfy the coroutine. Come into test character, and let's do a couple small tests. So what I'm doing is just creating our sprite character and Live 2D character, setting them at a different position, and then transitioning them both to the color red with a slow fade speed. That way I can interrupt it and unhighlight them both and see that change their color, and it shouldn't override anything. And then we'll just go ahead and highlight them afterwards so we can see it re-highlight them. Okay, we can see they're both transitioning their colors, and then darken kicks in, and then they both highlight. Okay, cool. So that's still working. Live 2D looked a little wonky there. Let's go ahead and remove the target color since we're not doing anything there. But for highlighting, let's only change that if we're not already changing the color on this character, because when we highlight, if we're changing the color, since it's using display color, it's automatically going to know if there's any change in the highlighting for the character. So we don't need to run this if it's already running a color transition. So if is changing color, or if not is changing color, then we'll go ahead and do the transition for the highlighting. And now we can see that the darkening and color transitions just look a little bit better on the Live 2D character there. Okay, with that out of the way, let's go ahead and finish up our model 3D. Let's do the same thing for this character that we did for Live 2D by first checking if we are not changing color. If we're not changing the color, then we'll go ahead and perform the highlighting color change. Otherwise, changing color is going to detect the highlighting change automatically. Okay, so what do we do when we're changing the color? First thing that we'll want to do is we'll want to cache the old color. So let's define that color, old color, by getting that from the renderer.color. After we've got the color, let's go ahead and run the transition. So we're going to be using lerp, so let's go ahead and create a color percent to keep track of. Set that to 0, and then just check while our color percent is not equal to 1. And let's run this. So while we're running this, each time let's go ahead and say that color percent, we're going to add an amount to it. We need to add a default transition speed, just like we did for our other characters. Do we have that defined up here? We do not. We have an expression transition speed. So let's go ahead and define a private constant float default transition speed and set that to something like 3. And then let's go ahead and say we are going to add the default transition speed times whatever our speed multiplier is times the time.delta time. And then let's apply our renderer color. So renderer for the active renderer dot color equals color.lerp, and then we'll go from the old color to the display color by the color %. And now we need to reflect those changes in all of the old renderers. So for each var, or, and old renderers, let's say or.old_image.color equals the renderer.color, perhaps. Yeah, let's do that. Let's say renderer.color. Okay, and once we're finished with all that, we'll say co changing color equals null. So we should be able to change the color of our 3D character based off the renderer image that's being projected on the screen. We can verify this by creating a new model 3D character and then performing the same logic on the other characters by changing and transitioning the color, then unhighlighting and highlighting to make sure that everything works as it should. And there we go, colors transitioning and colors darkened, and then color gets lightened. Let's go ahead and move on to the last thing that we need to override, and that is to get our facing direction for our character to make them face left and face right. So we can override that function with a public override and then face direction. And let's just go ahead and remove this one line. Okay, so we need to figure out which direction this character is going to face. If we look at our character in the scene, the model container is what's going to have the rotation for left and right. And we can see that my default here for this character is 25, and it'll probably be the same for each of the characters. I'm just going to leave it at just at that value, so that way I have something constant between all the characters, and if I need to adjust things and fine-tune them, I'll do so inside of the actual character model. But the model container will flip from left to right. So 25 is for the default direction, which is left, and negative 25 would be for facing right. So let's go ahead and cache this inside of our script so we can determine the right direction. We can do that by heading up to the very top of this script and making a new constant, a private constant, and let's make this a float for the default facing direction value, and we'll just set that to 25. And then back at the bottom, let's go ahead and determine what our facing direction is going to be for this character based off of our face left boolean that we're providing. So this will be a vector 3, and we'll run it off the Euler angles for the actual model container. So vector 3 facing angle equals new vector 3, not 2, vector 3, and x is going to default to 0. And then we're going to check if we are facing left. No, check the boolean, not whatever function that is. If we're facing left, then we're going to take the default facing direction value. Otherwise, we're going to take the negative default facing direction value. And then our z value will just be 0 as well. Okay, so that's our direction. Now, let's figure out if we're making this immediate or not. So if this is an immediate transition, then the only thing we need to do is we need to say that our model container needs to face that direction. So model container dot local Euler angles equals facing angle. And there's no need in us making a transition if it's immediate, so we'll operate off of the same model container. Otherwise, we're going to need to duplicate the character, duplicate the renderer, and duplicate the image that it renders to on the screen. So we'll go ahead and make a function for creating a new character rendering instance. And let's do that right up here. Private void create new character rendering instance. And we'll just say to do that right down here. Create new character rendering instance. Okay, so what we're going to do here is basically kind of what we did when we created our character up at the top. As a matter of fact, I'm going to copy all of this, but we're going to change quite a bit of it down below. So let's go ahead and paste all of that in here, and if I went past that real fast, that was just inside of our constructor when the character is first created. So all of this takes care of assigning the render group, setting the names, and all that good stuff. Now the first thing that we want to change is we want to make sure that we add our current renderer to the old renderers list. That way we have a copy of it and we can remove it and get rid of those unneeded instances later on. So old renderers dot add, and let's make a new old renderer, and this is going to take in our renderer CG. Oh, actually, we don't have a renderer CG, so we did, but I changed that to root for a different purpose. So let's just duplicate that and make a renderer CG as well, and have that get the canvas group off of the renderer, because we need that as well as the root, which controls the overall character. So now let's say our renderer CG is the canvas group for the old renderer, and then our renderer is the image itself, and then the render group that we currently have is the group for this that needs to be deleted. And again, that render group contains the character and the actual model. So we're duplicating all of that, and we're going to transition it out and then remove it once it's done. Okay, so now we can remove this. We're not going to load the render group prefab from resources because we already have a copy of it instantiated in the scene. So what we're going to do is instead just specify the render group here, and we're going to also specify its parent as our current render group's transform.parent. And we'll leave this the same because we do want to keep the name of this render group, and it's already going to be active, so we can remove that line. Now, camera will come from our render group. Our model container will also come from the camera, so all of this stuff is going to remain the same. What we'll do down here is let's go ahead and cache the renderer name. That way we can apply it to the newly instantiated renderer that we create. So string renderer name equals renderer dot name. Once we've got that, let's also get a copy to the old render texture. That way we can just duplicate it. So texture old render texture equals renderer dot texture. And now let's go ahead and create a new renderer. So renderer is going to equal our object.instantiate, and we're going to create a new renderer from the renderer.gameObject. Again, this is the image that our camera and our render group is going to project to, and we'll parent that to the root of the character for the layers anyway, which is going to be the renderer.transform.parent. And then let's not forget that this needs to be the raw image, so we'll go ahead and get the component of the type raw image. There we go. So we got our renderer. And then renderer.name equals the renderer name that we cached a second ago. And we need to make sure that the alpha of this renderer is 0 so it can fade in. So renderer cg.alpha equals 0. And now let's go ahead and create the new texture. We don't need to load it from resources. We've already got the copy of it right here. So new render texture as a clone of the old render texture. So we copy those settings. But we need to specify this as a render texture. And then we set the texture and we set the camera's target texture. And now we just need to position it in the screen. So when we create new characters, they're going to be positioned vertically. But when we create new render groups, we can position those horizontally to be on the same row as whatever character that we're cloning. So render group.transform.local position is going to, we're not going to add anything to it. We're going to set that equal to vector3.0. So it starts at a local point. And then we're going to add to that some sort of value. So vector2.0 plus whatever we're going to do in here, which is going to be vector3.right. We'll move it to the right. And we're going to multiply that by some kind of value. It's going to be this. We'll stick with the same stacking depth. We might need to change that later depending on the width of these characters. but it should work for right now. And then we need to get some kind of value here for however many stacking spaces we need to put here, and we can easily figure that out just by referencing how many old renderers we have. So old renderers.count would be a good way to figure that out. But if we go ahead and run this and we actually duplicate, like let's say we flip the character and now we have an old renderer and a new renderer, the new renderer is going to be created at the right, and then the old renderer on the left is going to be destroyed from the scene, so now that space is empty in the UI. The moment we create a new one, since we have no new renderers or no old renderers, it's actually going to try to create the character inside of the space of the newly created current character. So let's go ahead and reset the position for any of the renderers before we go ahead and apply this value. And if that didn't make much sense while I was saying it, then here's a little visual example of what I mean. When we create a new render group, what we're going to do is we're going to duplicate that and then figure out how many old renderers we have. We've now created this new render group, so then this one is our old one, which means we have one old renderer, so we would move this over by one space. Well, once that old renderer is destroyed, it's gone from the scene. And the moment we try to create a new character, instead of going over here or over here, it's going to figure out that, hey, we have like no old, we have one old renderer because that's this one being overridden. So it's not going to position it here, but it's going to position it here, and they're going to be in the same spot. So we'll be rendering two versions of the same character. So what we need to do instead is when we create another old renderer, we need to take the current renderer and whatever old renderers we have and move that over into the proper space. So let's quickly iterate through any of the old renderers that we have. Let's get that old renderer and grab the old render group and say transform.local position equals vector3.0, and then we're going to add to that vector3.right multiplied by I for the indexing. So it'll position all of these appropriately no matter how many we're trying to create, even if we've already destroyed all of the old renderers. That way none of them will render on top of each other and we won't get any kind of confusing images on the screen. So with that out of the way, we have now created a new rendering instance, and we can go ahead and take care of this now. So we can set the angle of the new renderer that we created to whatever the facing angle is that we defined above. So all these values are up to date, so we can simply just reference model container and say local Euler angles equals facing angle. And then let's go ahead and try to fade that in. So let's grab the canvas group new renderer equals renderer CG, so we can just go ahead and fade in that image and just do a loop while the new renderer dot alpha is not equal to 1. While it's not equal to 1, we're going to go ahead and just go ahead and say new renderer dot alpha equals mathf dot move towards, and we're going to move from the new renderer dot alpha towards the target, which is 1, by some sort of speed, which we'll go ahead and define up here for neatness. Float speed equals our default transition speed times time.delta time times a speed multiplier that we have passed into this function. And we'll go ahead and pass that in here and yield return null. Once we're done with all that, we can go ahead and cancel out the coroutine by saying co flipping equals null. And that takes care of that. So that'll fade in our new renderer, but that doesn't fade out our old renderers. So let's give ourselves a way to fade those out. I'm going to separate control into a separate coroutine for the old renderers. That way, as we call flips and face directions, if we do that multiple times, we don't have to keep restarting that for the old renderers. We'll just simply add on to the old renderers, and the current running coroutine will go ahead and fade them all out. So let's go to the top and define a couple variables that will help us run this coroutine. beneath all of our variables, I'm going to go ahead and define a private coroutine called CO fading out old renderers, and set that to null. And then give myself a private boolean is fading out old renderers, and set that to true if CO fading out old renderers is not equal to null. And I'm also going to want to cache the speed at which we fade these out, because since we're not recalling this over and over again, we're just going to go ahead and cache in whatever speed it is that our last flip was using, and we'll use that as the current transition speed for all of these old renderers to fade out. So private float old renderer fade out speed multiplier. So there's no confusing what that is. And by default, we'll just set that to the default transition speed. Okay, so now let's go ahead and create whatever coroutine is going to run that for us. This will be a private IEnumerator fading out old renderers. And inside of here, let's loop through all of the renderers that have an alpha greater than 0. So while old renderers dot any, so we need to use the system.link namespace. While any, we'll call each one O and just check if O dot and we'll just check if O dot old CG, which would be for the image, dot alpha is greater than 0. So if the old renderer's image still needs to fade out, then let's go ahead and fade them all out. Let's define the speed that we can apply to every single one of them, and that speed is going to equal exactly what we defined down here. So I'm just going to copy that line and paste it here, except we need to change speed multiplier for the fade out speed multiplier. And just so we know how this is going to be called, right before we go into the main loop here, let's go ahead and define that. So the old render fade out speed multiplier, we're just going to set that to whatever the speed multiplier is for this current flipping or facing call. And then if not is fading out old renderers, then CO fading out old renderers equals character manager dot start coroutine fading out old renderers. So it'll try to start that whenever we try to flip. And while it's doing this, once we have our speed, then let's go ahead and apply that to every single one of the renderers. So for each var OR in old renderers, we'll go ahead and say or.oldcg.alpha equals mathf.moveTowards, and we're going to move towards the or.oldcg.alpha. That would be our starting point. We'll move it towards 0 by the speed. And make sure we yield until that's done. Once we've finished, they're all faded out, so now we can go ahead and destroy the objects that we no longer need in the scene. We'll go ahead and loop through each one of these. And there are two things that we need to remove. We need to remove the image that's rendering on the main canvas, and we also need to render or remove the renderer that has the camera and the old model. So we'll reference object.destroy, and we're going to destroy the or.old group. So we'll destroy the camera and the model, and then object.destroy or.oldcg.gameObject. So we'll destroy the old image. And then we'll go ahead and clear out the old renderers list, so there's nothing left in there. And then CO fading out old renderers equals null to cancel that out. Okay, that was a lot, but assuming that I coded everything correctly there, I believe that we should be clear to go ahead and start flipping our 3D character. So let's go and test character and just try that. Instead of highlighting the character, I'm going to go ahead and make the characters flip. So Stella face right, Mal face right, and Amaria face right. And then face left. We'll go ahead and do them all just like that. So let's go ahead and hop in Unity and let's try playing this and see if it all works. So we should wait and... okay, nice. Yep, okay, cool. So that's working. Working like a champ. So we can see that it's now fading between the directional transitions for the 3D model character, which is a nice little feature to have. Of course, you can always set your own functions for these characters to control the actual rotation of the object inside, so instead of modifying the orientation of the model container, you can make a function that modifies the actual character model, and then just change the rotation of that object to fit whatever it is that you want to do for your character. Okay, so that has been quite a bit of a journey there. But that's all that we're doing for our characters. We've already got all of the actions and the main functions and everything that all of these characters need to run in the visual novel, so that's it, and we're good to proceed on to the rest of the series. And the next video, we're going to start focusing on implementing everything that we've done so far into the dialog files. So now we won't have to run them through script. In the next video, we'll be able to actually run them in the dialog files and have all of this stuff happen behind the scenes for us. Again, for 3D models, there are many ways that you could implement these into the visual novel. If 3D models is all you're planning on using, then maybe just having that separate canvas and rendering them all in a single render texture, controlling their depth independently. You may have specific ways that you can do that, but for this instance, I think this will do just nicely. Just use discretion for your project, and you will be just fine. So that's it for this one. I'm going to end this video off, and I hope you all had a great time, and I'll see you guys in the next video. Bye.